In this recording, we're going to look at solving quadratic equations algebraically by factoring. So far we've looked at solving them graphically, and now we're just going to build on that and solve by factoring. So this should be a review from your Algebra 1, but let's go through it together. So in this case, we've got a quadratic to solve here, and it says explicitly refer to the zero product property. So let's make sure we do that as we're working through this. So first off, I have to get it in what's considered standard form first, right? I have to get equal 0 on one side. So I'm going to subtract 14 from both sides so I can begin to get it into standard form. Okay. At this point, we can think about factors that multiply to be negative 14 and add to negative 5. Certainly can make a box if you like. And either way, you're going to end up with x minus 7 x plus 2 equals 0. So here's where we're going to refer to the zero product property. The fact is, I have two factors that multiply to be 0. So what that says is, one of these factors must be 0, or both, if the product is 0. You're multiplying two numbers, their product is 0. One of those numbers must be 0, right? That just kind of makes sense. So when we talk about the zero product property here, we're going to set each of these factors equal to 0 using the zero product property. Okay, so those are our two values of x that would make this true. That would basically make, in this case, the equation equal to 14. We could check that by substituting in. Next, I want to express this in factored form. We said every time, what is it that we're looking for first? GCF. So hopefully you're looking for your GCF. You see that there's a 2x that is the GCF. So let's factor that out. So f of x is equal to 2x parentheses x minus 6. So that's our factored form. In terms of the solutions to when f of x equals 0, well, that's when the left side equals 0. And again, we're going to utilize the zero product property. Two factors, actually three, a 2 and an x minus 6 quantity, all multiplied to be 0. So that must mean that one of these factors equals 0. Well, 2 can never equal 0, right? But 2x, we can go over here and do some work. You can divide both sides by 2 and get that x equals 0. Or you could just say, hey, 2 can never equal 0. Either way. And now we're going to refer to the factor x minus 6 and see what happens when that equals 0. Well, the only number that solves that would be 6. Okay. Now let's make another connection back to the graph. What are our x-intercepts? If we were to graph this, well, what are the places where y would equal 0? Those are x-intercepts, right? Well, we just solved for that. We just solved for when f of x, or y, equals 0. So our x-intercepts would be the points 0, 0, and 6, 0. Finally, at the bottom here we have some fairly challenging polynomial equations that we're going to look to solve using some of our quadratic factoring techniques. So remember, we always look for our greatest common factor anytime we're doing any factoring. After we've dealt with that, we look to pursue other factoring techniques. So let me leave you to factor these and get as far as you can with factoring. Then play the recording when you need a hint, or you're ready to check your answers. All right, so hopefully you got as far as you could with this one, possibly getting totally factored. I'm looking for a greatest common factor first. I don't see any numbers that go into them, but I do see an amount of x's. I see x cubed. So let's pull out an x cubed and write it as 6x squared minus 7x minus 5. Okay. The x cubed is already factored. I know its factors are x and x and x. It's this quadratic now that I'm going to try to break out in factoring. If you remember, we don't have a GCF here. I'm going to multiply 6 times negative 5, get our little list for negative 30. So I'm looking for numbers that multiply to be negative 30 and add up to negative 7. So I've got like 6 and 5. I'll make one of them negative. That doesn't work. 10 and 3. That will work. Okay, so we'll box it in. we're going to go with 6x squared in the top left, negative 5 bottom right, and then negative 10x, and 3x in our remaining squares. Now we're going to take our GCFs of 2x and 3x, and the rest is easy. 2x times what makes negative 10x? That's a negative 5. 3x times what makes 3x? Well, that's a 1. I see my factors. So now we can write it out. X cubed, I just have to shift it slightly. My remaining factors come from the dimensions of my area model here. 2x plus 1, 3x minus 5. And now we're just going to solve each one of those, set them equal to 0. Okay? So using our zero product property, we're going to say x cubed equals 0, 2x plus 1 equals 0, and 3x minus 5 equals 0. So each one of these can be solved. When you cube root a 0, you just get 0, right? So that's one of the solutions. When you subtract 1, divide by 2, you get negative half. When you add 5 and divide by 3, you get 5/3. So those are our 3 solutions to this pretty complicated looking quintic. That's a fancy mathy word for a 5th power polynomial. All right, for this next one, we use a different color. Let's go with green. If you haven't done this one yet, now you got a little hint, go ahead and do it. So hopefully you worked this one out. We see a x cubed again is our GCF. Let's pull that out, and I see an x plus 3 as a remaining factor. Again, using our zero product property. Something times something equals 0. That must have meant that one or both of these had to have been a 0. So work them out. That again is 0. And here it's negative 3. So those are our 2 roots or solutions. Finally, let's go with the blue pen. Let's look for GCFs first. I see a 2 that goes in all the terms. I also see an x squared. So let's pull out a 2x squared. That's the remaining factor. Let's factor what's inside the parentheses here. Not quite as complicated as the one we did in purple. Just 1 times 4 is positive 4. And so I'm looking for numbers that multiply to be 4 and add to negative 4. Well, that's going to be negative 2 and 2. Negative 2 and negative 2. Setting each of these factors equal to 0. Using our zero product property, we get that x equals 0, x equals 2, and of course x equals 2. I'm not going to write it a second time. Those are our solutions. Thanks for watching.